calculus students. I had an office hours question today about exercise 31 from the textbook from section 9.1. And the textbook refers to exercise 21. So I'm going to actually answer exercise 21 first, and then I'll answer exercise 31. Isla, do you want to say hi? My daughter, who will be turning 6 in quarantine on April 19th, Isla, would like to say hello.
Hi!
All right. So exercise 21 is a geometric series, and it's an infinite. So exercise 21 is a geometric series. So if I start at 0, everything to the 0 power would be 1. If I use n equals 1, I have 2x. If I use n equals 2, I have 4x squared, etc. And then my general term is 2 to the n, x to the n.
I can calculate what you asked me, okay?
Okay.
Even though if it's far away, I'll go as
All right.
close as I can.
And then, because this is geometric, it will be equal to a over 1 minus r. But for us, a is 1. And r is 2x. And this is a true statement, but it's not a true statement everywhere. It's only a true statement if r is between -1 and 1. And since r is 2x, it's only a true statement if 2x is between -1 and 1.
Calculator.
Okay, Leo, I have to divide -1 by 2. What do you get when you divide -1 by 2?
I think -2.
Not multiply by 2, divide by 2.
Oh, okay, that's 0, right?
Oh,
Yeah, -1/2.
-1/2. So -1 divided by 2 is -1/2.
Weird, right?
And then I need to do +1 divided by 2.
Easy, 1/2.
Okay. So this is the interval of convergence for this geometric series because our multiplier has to be between -1 and 1. So for 21, this is a true statement as long as x is between -1/2 and 1/2. Now I'm going to look at 31. 31 says, what if we take the antiderivative of both sides of this equation? So I want to know the integral from 0 to x of this thing. So I'm going to do the integral from 0 to x. Our function has a t in it when I'm doing the integral so that I can do that.
And how about I say hello?
Well, come on over if you want to say hello.
Maybe you could just introduce me. Like, Leo's commenting on some selves, and he's also going to answer some questions. Yes. But there's got it, Mom? Got it?
I got it. So I'm just doing to both sides of this equation, I'm going to do the integral from 0 to x. On the left-hand side, if I'm doing an integral of that from 0 to x, I would do antiderivative. So I would do the antiderivative of 1, which is t. The antiderivative of 2t is t squared. The antiderivative of 4t squared would be 4t to the third over 3. And then the antiderivative of 2 to the n, t to the n would be 2 to the n times t to the n plus 1 over n plus 1. And then I would evaluate that from 0 to x. And the other side of the equation, I have 1 over 1 minus 2t, so I'm going to need to do a u substitution. So u is equal to 1 minus 2t. And then du would be -2 dt, and that means that dt is -1/2 du. So when I do that substitution, I have 1 over u times -1/2, and I'm going to evaluate it from, if I plug 0 into my u definition, I get 1. If I plug x into my u definition, I get 1 minus 2. Oh, I haven't done an antiderivative yet. I'm sorry. Let me back up. So I have -1/2. I'm going from 1 if I plug in 0. If I plug in x, I have 1 minus 2x. And I'm doing 1 over u, du. So on this side, I have natural log of u. So I have a negative 1/2 times natural log of u from 1 to 1 minus 2x. On the other side, it's really straightforward because if I plug in x, I get exactly this, but just with x's instead of t's. And if I plug in 0, I get 0. Ah! It went away. There we go. So on the other side, I have x plus... I lost... Stop. Sorry. We're doing a smile. So I have x plus x squared plus 4x cubed over 3 plus etc. All that has x's in it instead of t's.
When will I do something to help you?
I don't know if there's something to do on this one, Leo. And then on the other side, antiderivative. So now I'm going to plug in my numbers. So I have negative 1/2 ln of 1 minus 2x. Minus negative 1/2 ln of 1, which is 0. Oops, I wrote that wrong. And this is a true statement because we just did the same thing to both sides of the equation, but it's only a true statement on the interval of convergence. So 31 has the same interval of convergence that 21 had. All right. Hope that helps. It was a little bit distracting, and I think I won't do the video for the next one. All right. Take care.